It says combining the ideal gas law and Avogadro's law gives you the ideal gas law equation. And this right here is the equation. PV is equal to nRT. P, of course, is for pressure. Now we will explain why, but pressure has to be in atmospheres. The volume has to be in liters. And before, you could have any quantity or any type of measurement there. You could have milliliters, for example, in volume, or you could have torrs in pressure. But here we've got to have these specific units for this ideal gas law to work. So pressure has to be in atmospheres, volume has to be in liters. N here is the number of moles, and that's the new thing that we're introducing here. And then we have a gas law constant. And in the gas law constant that we will be using is 0.0821 liters atmospheres Kelvin mole are the units that go with the constant. And so our volume has to be in liters, our pressure has to be in atmospheres. As before, our temperature has to be in kelvins and then moles. There are different gas law constants that can be used when you change these values, but it'll make it easier for us to learn to keep with this gas law constant, the 0.0821. Temperature, of course, is in Kelvin. It says here the law allows you to predict the effect of changing temperatures, pressures, and volumes and changes in the amount of gas that you have. So let's work a couple of problems with this. It says, what is the volume of an expandable container of gas when 800 grams of dry ice vaporizes at 5 degrees C and 760 millimeters of mercury? So let's see if we can work this one out. The first thing that we'll notice here is that we have a gram amount, and that's a dead giveaway that you're going to use the PV is equal to nRT. Before, we didn't have a mass to work with. And it says, what is the volume? Okay, so we're isolating volume. So now volume will equal to nRT over P. We'll multiply through by 1 over P here to isolate the volume variable. And before we can plug in here, we're going to have to do some converting. The first thing that we're going to have to do is convert grams to moles, right? Because N is equal to moles. So we have 800 grams of CO2. And so to change that into grams, we'll have to look at the periodic table in the molar masses of carbon dioxide. Carbon, there's 1 mole of carbon, 12 grams per mole. Gives us 12 grams total, of course. And then we have oxygen. We have 2 moles of oxygen at 16 grams per mole, which will give us 32 grams here. So we get a total of 44 grams per 1 mole of carbon dioxide, per 1 mole of CO2. Okay, if we do the math there, 800 divided by 44 will give us 18.2 moles of carbon dioxide. Okay, and then we said that our R value here, our R value is equal to 0.0821 liters atmospheres, Kelvin, and mole. So now we've got to make sure that our other variables here are in those units. And we see right away that they are not. We have 5 degrees C, and so we will have to change that to Kelvin. So 5 degrees C plus 273 will give us 278 kelvins, right? And then we're going to have to change our millimeters of mercury to atmospheres. So 765.0 millimeters of mercury, 760 millimeters of mercury is equal to 1 atmosphere. So we'll have to convert that to atmospheres. And when we do that, we get 1.01 atmospheres. Okay, so now we're ready to plug into our formula V is equal to nRT over P. So our N is our number of moles right here. So it'd be 18.2 moles. We'll just put an N there. Our R value is 0.0821 liters, atmospheres, Kelvin, mole. Our temperature is 278 K. So there's the top part. Forgive my squiggly line there. And the pressure we just did is 1.01 atmospheres. So if you multiply across the top there, 18.2 times 0.821 times 278 divided by 1.02, you will come up with an answer. And let's see what the answer's units will be and make sure it's in a volume. The number of moles will cancel out, kilograms will cancel out, atmospheres will cancel out, and so our final answer will be in liters. And I believe that the answer there is 411.2 liters. Alrighty, and that would be liters of carbon dioxide gas, right? So kind of a long drawn out process there. The hard part is just making sure that you have your variables in the right units so that they will match the R value or the constant value there.